Now that we've got a good sense of exponent rules and kind of how to simplify some expressions, we're now going to introduce an actual real world situation in which exponents are really helpful, and that is scientific notation. So in general, it looks something like this. So we'll have a number times 10 raised to some power. And a is going to be a number between 1 and 10. It can be 1, but it cannot be 10. So we'll write this like this. We'll say that a, it can be greater than or equal to 1, if I'm reading it right to left in this inequality. A is greater than or equal to 1, but it has to be less than 10. So A can be 9.9999999, but not 10. And where scientific notation is used, you use it to express very large or very small numbers much more concisely, or taking up less space on your page. So for example, the Earth is 92 million miles from the sun. And so this is a pretty big number. It's got 6 zeros, 8 total digits. So if I was working on some problem or studying the Earth from the sun, for example, and this number kept popping up, I could write this number as many times as I need, or I could express it in scientific notation and write it like this: 9.2 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8. Pretty sure it's to the 8th power. And I will show you in a moment on how we go from numbers like this to scientific notation, as well as the other way around. The first thing we're going to do is practice going from scientific notation form to standard form. So getting things, and looking at the last example, we want to go from this to this. So scientific notation form to regular old number. So looking at this example, this is definitely in scientific notation form because I have some number times 10 raised to some power. So the first thing you want to do is take whatever number is a, so in this case it's 3, and write it in decimal form. So instead of just 3, I'm going to write it as 3.0. And if your number, or if a in your example already has a decimal, then you don't have to do this step. Just take it in decimal form. The next thing we're going to do is we are going to move this decimal right here to the right this many times, or whatever n is. And we're moving it to the right because in this case, n is positive. It's a positive 4. So I'm going to take my decimal and I'm going to move it 1, 2, 3, 4 places to the right. And then in these spaces here, right, in these spaces there, we're going to put zeros. So converting 3 times 10 to the 4th, which is scientific notation, to standard form, just a regular old number, is going to give us 30,000. Here's some examples to kind of practice what we just talked about. So over here, 9 times 10 to the 3rd, I'm going to write 9 as a decimal first, so 9.0. And then we're going to move the decimal place to the right because the exponent is a positive 3, and we're going to move it to the right 3 places. So 1, 2, 3. So decimal place is there, and we're going to put zeros in those little U things leading up to it. So 9 times 10 to the 3rd, that's scientific notation, expressed in standard form is going to be 9,000. All right, 1 times 10 to the 1st, well, I will express 1 as a decimal, so 1.0. And then we're going to move the decimal place again to the right because that 1 is positive, just 1 place, so move it over here. And I don't need to add any zeros because that 0 right here is already there. So our answer is going to be 10. And just remember, like, you don't have to have 1 in your exponent. It's kind of redundant. So this is really just like 1 times 10, which is 10. but just to illustrate the point with scientific notation, we'll do that this way. Okay, 2 times 10 to the ninth. So again, I'm going to write 2 as a decimal, so 2.0. And then we're going to move the decimal place to the right 9 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And put zeros in everywhere else. 1, there, and there. So our number in standard form from 2 times 10 to the ninth is going to be, let's see, that looks like 2 billion. So 2 with 9 zeros after it. All right, so over here we have 7.3 times 10 to the fourth. So our first number, or A in this case, already has a decimal, so I don't need to rewrite it with another decimal. I can just leave it like that. And we're going to move the decimal place to the right 4 times. So 1, 2, 3, 4, right there. And I will put zeros everywhere else. 7.3 times 10 to the fourth, expressed in standard form, is going to be 73,000. Right, 12.05 times 10 to the sixth. So again, this number already has a decimal, so I will just copy that down and then move the decimal place to the right 6 times. So 1, 2, 3, 4, 5, 6. Put the decimal there and throw zeros in those placeholders. So this will give us 1205 with 1, 2, 3, 4 zeros, and that'll be 12,050,000 as the standard form of 12.05 times 10 to the sixth. So again, when you have a positive exponent for 10, you just take your decimal and move it to the right, whatever the exponent is that many times. If you're curious as to why that trick or that shortcut of moving the decimal place works, let's look and see what's actually going on. Let's break it down. So 3 times 10 to the fourth. What is 10 to the fourth? That's 10 times 10 times 10 times 10. So I'm going to, let me replace 10 to the fourth with what I just said. So I'll have 3 times 10 times 10 times 10 times 10. Remember, this is 10 to the fourth. And now we'll just do our multiplication going left to right. So 3 times 10 is 30. And then I'll have times 10 times 10 times 10. 30 times 10 is 300 times 10 times 10. 300 times 10 is 3,000 times 10. And then this 3,000 times 10 is going to give us 30,000. So the shortcut is move the decimal place to the right, but you can see here this is what's actually going on.